We are getting more attendees. Great. Settle in. So yes, this webinar will be recorded. Okay, so if you have any questions, please write them in the chat. Okay. And then at the end, if there are any questions, we will address them. Okay. In the meantime, please settle in, and then we can start. I'm going to start here. Right. See more people coming in. Terms of, okay, great. Oh, sorry. Okay. Oh, oh, sorry. Okay. Yeah, I think we can start. Yeah. Well, thank you so much for attending today. My name is Rui Oliveira, and alongside Andrea Puentes, we're going to be the moderators for this webinar. Okay. So this webinar is about how we are advancing the European PV sector with artificial intelligence. Okay. And we have two projects with us today. Okay. So basically, what's going to happen is basically we're going to introduce a bit about TALOS and about PVOP. Okay, we're going to have some project presentations. Okay, and then we're going to have a panel discussion. Okay, about the European PV sector, what are the key trends, policies, and the challenges of the sector. Okay, we're going to have a moderator, which is going to be me and Andrea, and obviously João and Luis Navarte, which are João Gaspar is with EDP Portugal, and Luis Navarte is with the Universidad Politécnica de Madrid. And then we're going to have the closing remarks. Okay. Yes, so as I was saying, yes, these are our speakers today, okay? So Luis is a renowned researcher. He has worked with the PV sector for a long time now, and João is the R&D engineer within Talos, and they've been working in their respective projects together and trying to advance a bit of the European solar sector, okay, through AI, through robotics, and through different innovations in these fields, okay. So right now I am going to give the floor to João. He's going to be the one who is going to present the Talos project, what they have been up to in terms of newest advancements and so on. All right. So João, you have the floor. I'm going to stop sharing my screen and you can share. Yeah. Oh, sorry.
Thank you very much. I hope that you can see my screen.
Yes.
Okay, so thank you for the opportunity to be here presenting Talos. So my name is João Gaspar. I work at the R&D Center of EDP, an energy utility company that is also coordinating the Talos project. And as part of the coordination team, I'm here today representing it. So Talos is a project that started in October 2023. It has an expected duration of 36 months, so it will last until September 26, with a budget of 10.5 million, among which 1.8 dedicated to funding an open call for SMEs and startups, And the overall scope of TALOS is to improve O&M activities in PV systems using automation and AI. The aim of the project is to achieve, with a different set of solutions, a TRL of 6 to 7 by the end of the project, which means that we are targeting the demonstration of prototypes in operational environments. An overview here of the partners that are involved in the consortium. So in total, we are 14 from all over Europe, ranging from academia to several industrial partners, both from software and hardware, and then some end users involved in the project as well. In terms of what motivated this project, so going a bit back in time, there were several drivers behind it. On one hand, we knew that PV plant sizes were growing a lot in terms of size and installed capacity. Many of these power plants, the bigger ones, were being built away from large human settlements, which made having people around to perform O&M tasks and to operate the pilot site more difficult than usual. We are also aware that workforce with solar skills is scarce and threatens to compromise EU targets, both in terms of installations and then in terms of O&M. And then finally, solar plants are power generating stations, so meaning that they are places that have some types of hazards, which can put human health and safety at risk. And these factors together, they highlight the need for increasingly making O&M activities more autonomous, either the ones that are currently being performed by humans or that perhaps are not even being performed at all. And so TALOS was born with different sets of objectives. So first of all, we wanted to develop an ecosystem with high quality robots that would be able to have mission planning, that would be able to operate autonomously, and also to collaborate with each other and with the humans in the loop. Then a second objective was to demonstrate these robots performing some of the most relevant O&M tasks in PV systems, so inspections, cleaning, vegetation management, to name a few. And to support this robotics part, we are developing advanced AI algorithms to model the PV plant behavior and to make the robots or to be able to identify anomalies and calls for action for the robots in the PV plants. These insights that might be gathered with the AI systems then feed into a recommendations engine that then can trigger the robot missions. Then on another vertical, so TALOS not only focuses on conventional PV plants, but also on floating and agri-PV systems, which are emerging. And so from the start, like to promote adoption of automation AI to these systems will contribute for these types of projects to also become more sustainable and viable in the near future. Another objective of the project was to involve the end users in the co-creation of solutions to make sure that the solutions from the beginning, that they ensure the adequacy for real-world application, and also to involve the end users and to make them adopt and embrace these solutions from an earlier stage. And finally, a core objective was as well to have this 1.8 million to fund. In this case, we ended up funding 12 startups and SMEs that were addressing other challenges in O&M in PV systems that were not being directly addressed by the project itself, the consortium itself. So here a brief summary of the developments inside the consortium. So we have this robot-human collaborative environment, which gives the end users the possibility to control and to manage robotic missions. Then we have a set of PV monitoring and inspection algorithms. So as I mentioned, for the detection and classification of faults, and to provide recommendations of O&M actions that need to be made. Then we have a set of robots, so autonomous robots, one mower in the land-based PV, two cleaning robots, one for the land-based and one for the floating PV site, and then UAVs for aerial inspections in all of the PV sites. And then finally, more directed towards the agri-PV, we have an autonomous ground vehicle that will be used to perform monitoring of crops in the agri-PV setting. Here, I would just like to show some of the developments made in the project. So the UAV that I mentioned, being developed by one of the partners in Eshktech. So they leverage visual and thermography imaging and edge intelligence. So when the mission with this robot is triggered, they are capable of going to the location and to identify the type of damage that might be there. Then we also have another solution. My apologies. Another solution, which is the autonomous cleaning robot for floating PV platforms. So we have already had some demonstrations happening. Here we can see the robot going autonomously within a same row to do the cleaning. We have also been able to validate the robot crossing gaps in the floating platform. So this was quite a challenge actually to be able to achieve, but it has been achieved. Then we can also see here the robot cleaning without water, so just using the brushes that are on both ends of the robot. Ideally, the robot will be able to clean with water. It was designed to do so, but even without, we can see already a big improvement in the cleaning standards when it is used without water. And finally, we have also demonstrated already the automatic docking in that platform that you see there that allows to move the robot in between rows and also serves as a charging station. Okay, so these are just some examples of the work that is going on. We have many other results, interesting ones that we expect to be able to show soon. And all of this together comes to the final outcomes. So we expect to be able to improve PV plant performance by up to 10% with the type of automation that we are introducing. We expect to reduce human exposure to risk by 90%, to reduce the maintenance periods by over 70%, and as well to reduce O&M costs by up to 5%. So just showing a little bit the types of pilot sites that we are testing in. So as I mentioned, 3 different scenarios: land-based PV, floating PV, and agri-PV. The land-based PV site, it's located in Villacastin in Spain. It's an hybrid plant belonging to EDP, so meaning it has both a solar and a wind park sharing the same connection point. Here we are only testing in the PV site, which has a capacity of 28 megawatts, and we are testing the inspection drone, the cleaner, and a mower. Then we have the Alqueva site, which is in Alqueva in Portugal, with a PV plant capacity of 5 megawatts. And for this, we are testing also the inspection drones, a dedicated cleaner, and the boat that is able to carry the drones from land to the floating platform. And finally, we have the agri-PV site in the Netherlands, the Wageningen University, with 50 kilowatt installed capacity of bifacial and semi-transparent modules. And we are testing here as well the inspection drones and the crop monitoring UGV. And just to end the presentation, I would like to show as well some of the results from the open call. So as I mentioned, the idea for this open call came from the fact that we knew that there were a lot of challenges in O&M in PV plants that were not being able to be addressed directly by the partners in the consortium. And so we identified what these main challenges would be in each of the 3 types of pilot sites. We came up with the list of 18 plus 1 topics, probably many other interesting things that also need to be done, but these were the topics that we thought made more sense to address in the context of this open call, with activities ranging from XR tools to support O&M teams in their activities, also robots for inspection and maintenance of mooring and anchoring systems in floating PV plants, biodiversity monitoring solutions, microclimate monitoring to support the farmers. So you can see here a lot of different challenges. and we left it up for the startup and SME landscape to apply for it. This open call was launched and disseminated in different ways, so either via social media, renewable energy and robotics international forums, webinars, and I believe it was quite successful. We got 160 applications for this project, of which 12 projects were selected and then were to receive funding and undergo a 9-month support program. This support program is still happening. So first we started in April. We had a 1 month of planning of activities, 3 months for the development of the solutions, and now 5 months for the integration of those solutions within the TALOS ecosystem of solutions and to demonstrate them in real world. So we are now entering the last month of this demonstration phase. We already have some very interesting demonstrations in the field, so we are ensuring that these solutions are applicable to the real world scenarios. And yeah, I would just like to leave you with some of these images. So we had 7 of these beneficiaries were targeting the land-based PV pilot. So number 1, you can see a beyond visual line of sight drone to do inspections in large PV plants. As you can see, in terms of hardware, it differs from the usual drones, and so this enables it to run much faster these inspections. Then in number 2, we have an XR solution to support O&M teams that enables human-robot cooperation. We have as well a navigation and perception system for ground vehicles in number 3, which is able to provide robots with guidance and to avoid obstacles in the PV plants. And then we have number 4, another XR tool for enhanced cooperation, in this case, targeting the communication between the field technician and the dispatch center. In number 5, we have a biodiversity monitoring and alert system, which is capable of identifying different species and providing recommendations to the O&M teams and to the autonomous robots. And in number 6, we have an autonomous grass mower, which now also has AI-powered inspection capabilities, RGB and thermographic, to detect defects in the backshoots of the modules and in the connectors. There's another beneficiary, number 7, which is doing drone inspections for electroluminescence, which is still to be demonstrated in the next month. Then moving on to the floating PV, we have 2 companies, one of them developing an autonomous underwater vessel for inspection and maintenance of moorings. And number 8, we have another XR tool, which is being particularly adapted to the challenging environment of the floating PV. So due to its continuous movement of the floating PV platform and changing of coordinates depending on the water level of the reservoir, this solution is being targeted to address these problems in particular. And my last slide to talk a little bit about the developments in the agri-PV. So we have 2 beneficiaries, the number 9 and number 10, which are developing monitoring solutions for crop analysis and to provide recommendations for farmers. And then we have number 11, a robotic gripper that can autonomously identify, pick, and handle the fruits. Just to say that some of these open call solutions, some of them that require access to PV plant data, namely SCADA data, or that the objective of these solutions is to provide recommendations to the O&M teams or to the farmers, they are being integrated as well in the TALOS platform, which showcases one of the main objectives of the project, which is to create this ecosystem of solutions with open architectures where SMEs and startups can easily integrate and directly add value to the other, to the whole ecosystem. That's it on my side. Thank you very much, and I pass the word.
Thank you so much, João. Thank you for your presentation. I will now give the floor to Luis, and Luis can share his screen so that we can hear a little bit more about PVOP as well.
Thank you very much, Rui. Can you see my screen?
Yes, we can. Yeah.
Thank you very much. So, thank you very much to Funding Box for organizing this webinar. I would like to give you an overview of PVOP project, and I will start by saying that the main motivation of PVOP project is that the reality is showing that PV plants are performing lower than expected. And the truth is that the life of owners, those who build, operate, or maintain portfolios of PV plants, is very hard because this underproduction is not the only problem they are suffering. Any one of these stakeholders could make a list of problems like this one. Uh, they could say that the analysis of the benefits and the PV production of my PV plants are showing that they are below of expectations. Or they could say that the operating data and the alarms that we are receiving from the PV plants are so numerous that it's unmanageable for our team. Another problem is that the tracking algorithms of our solar trackers are not working well in undulating terrains, and we are having more losses than expected. Or they could say that there are numerous insulation failures that we don't know how to interpret. Um, Another problem is that there are performance losses for which we are not detecting the causes, or that the sale prices of PV electricity generated in our PV plants are falling, but the business models of including batteries to solve this are still not satisfactory. There are also problems with maintenance, and these stakeholders feel that the maintenance is increasingly difficult to manage and more expensive. So there is no longer permanent staff at the PV plant, and I no longer have a clear vision of what is happening there. Or there are questions like, should we do predictive maintenance to get ahead of problems, but when? How we should do that? Uh, so PVOP wants to be an answer to this long list of problems by developing AI power solutions for PV power plants to optimize their performance, to improve their performance, to their efficiency, and to increase their profitability. And this response is based on the development of the next generation of procedures for performance evaluations and failure detection in PV plants. So this generation of procedures are based on the following philosophy behind them. We want to ensure good operation data coming from the PV plants for us to be able to apply AI algorithms with the goal of increasing the performance and increasing the profitability of PV plant portfolios. In order to do that, we have included in the consortium a set of small and medium enterprises, very dynamic, with a faster response to the needs of the PV sector, and referencing these fields with access to more than 11 gigawatts of PV plants. They are currently evaluating the performance, doing failure detection in more than 500 PV plants all over the world. And these SMEs very oriented towards exploitations to offer the 8 solutions we are developing in PV project to any company of the PV sector. We are applying open science and citizen research techniques in order to involve the potential end users. So let me a word about this topic about good operation data and artificial intelligence. Good operation data means good sensorization in the PV plants. But according to the pressure of cost that the sector is suffering, we only want to measure what we need in order to detect failures. But we know we need low uncertainty in the measurements because some of the failures are reflected in a very low decrease in the PV production. So we need low uncertainty in order to detect this. And also, the result of these AI tools need to produce alarms, but we need a new alarm management in order in order the teams be able to manage them. Okay, so in the integration of artificial intelligence and PV, we have several changes. One is the temptation of data-centric artificial intelligence. This is not possible because we have a very young PV park. For you to have an idea about this, only 15% of the PV plants installed all over the world have more than 5 years. So we don't have a record of the technologies that are being installed right now because of the continuous appearance of technological innovations. So be careful with a data-centric artificial intelligence. We have opted for adding also human intelligence with huge experience in the operation and maintenance of PV plants in order to establish cause-effect relationships in the failures that we are detecting. But obviously, we need data of the past with other technologies, but data with operational data with PV plants with the current technologies. We have access to this kind of data thanks to the small and medium enterprises working in the consortium, but also to this deep experienced team that we have joined to the project in order to provide their experience. Increasing performance and increasing profitability is being done in three different axes. First, adjust the productivity expectations in the design phase of the PV plants. So we are developing software solutions in order to establish correct expectations. In the current reports, we are finding that the productivity of the PV plants is being 9% below expectations. And some of these points of lower expectation is due to an initial expectations very optimistic. So we have to correct this with new software solutions. The second ask is that we need to have fewer failures and for less time in order to reduce the decrease of performance. For that, we are producing solutions about automatic detection of failures with artificial intelligence. And the third ask is to maximize the energy trading in order to increase the profitability. We are working in solutions of integration of batteries with multi-energy management strategies and predictors of electricity market. So the set of solutions we are developing are these ones. First, a sensorization toolkit to ensure quality operational data that enables AI to be applied. Second, a smart tracking control for large monofacial and bifacial single-axis tracking PV plants over terrains of arbitrary orientation and slope for the performance optimization. Third, near 100% automatic AI-based system for failure detection based on a family of algorithms for fault detection and diagnosis of causes using the data recorded at the PV plant. The fourth one is a near 100% autonomous aerial inspection and fault detection system based on the integration of AI and high temporal and spatial resolution images, and also images with multispectral capabilities. Fifth is the solution of near 100% automatic and predictive PV asset management software to maximize performance and optimization of the O&M management in PV portfolios. And finally, we are developing a solution for the smart control of PV plants with batteries, with weather and electricity market forecast to maximize the energy trading. These solutions are being done mainly by these four partners: qualifying photovoltaics, focus on failure detection; aeroprotechnic, focus on aerial images; Batcraft, focus on solutions of integration of batteries; and ASIC 21 regarding the prediction of prices of the electricity market, not only of the price of electricity, but the prices of other ancillary services. Okay, just to show you some details of the solutions, you can see here trackers over terrains with a slope. You can see at the beginning of the day and the sunrise how we have shadows over the PV generators, but this is not only the sunrise. If you see what happens minutes later, but also hours later, you see that you continue having shadows over the PV generators with the underproduction that these produce. So we have produced solutions in order to consider terrains that this terrain seems flat, but you have different inclination between the trackers. So you can see light on the terrain that this reduces the irradiance gain on the solar trackers. So with our algorithms, we can put different angles in the different trackers in order to increase these irradiance gains. It's not only a matter of producing new angles, but calculating also the front irradiance and rear irradiance in case of bifacial PV plants. Regarding the integration of batteries, we are using multi-energy management strategies that we select on real time depending of the signals coming from an AI electricity market predictor in order to choose the energy management strategy that increase the profitability in any instant of operation. And regarding aerial inspections with artificial intelligence, in addition of the traditional thermographies and electroluminescence, we are applying ultra-high resolutions in order to detect microcracks, or we are using aerial inspections in order to detect misaligned trackers in very large PV plants, or hanging DC cables or vegetation casting shadows over the PV generators. But to stay on track and ensure solutions don't stray from reality, the researcher's mind must be guided by those who are experiencing real life problems, as reflected in the sculpture that is in the right of the slide. That's why in PVO project, we want to involve owners, builders, operators, managers, and maintainers of PV plant portfolios from the very beginning of the solution design through testing the solutions in their alpha versions till the validation and the real world operating conditions. With their continuous feedback, working together. That's why we want to invite you to jump on board of PVO project. And we have imagined some personalized discovery call for you to know the current development of these solutions, for you to help us to test them and to receive your feedback to orientate these solutions to your real needs. So here you have the links to this discovery call. Please enter if you want to know our solutions, if you want to help us with your feedback about the orientation of the solutions. Thank you very much for your attention. If you want or you need if you need me for anything, here is my contact. Thank you very much.
Thank you very much, Luis. And thank you all that were listening to it. I'm going to leave here some links for you, okay? Um, well, if you have any questions regarding the project, okay, please ask them in the chat, okay? Ask them, put them in the chat, and me and Andrea, we're going to ask some questions now. We're going to enter the live panel discussion, okay, with Louise and with João. And effectively, if you have any questions, please ask away, okay, and we will take that into consideration. Okay, so the first question from my side, and in this case for Louise, is actually what does a fully optimized European PV plant looks like in 2030, okay? And how close are we to that so far?
Thank you very much, Ri. 2030 is very close. So we have to run a lot in order to produce solutions that meets the needs of the PV sector by this date. PV plants in 2030 will be far more automated than they are now. They will have AI-based systems combined with robotics for maintenance tasks. That's clear. Perhaps some example will illustrate this better. Imagine an AI fault detection systems will detect underproduction in a specific PV generator at the plant. It will also diagnose that this is, for example, an open string in the PV generator. It will generate a repair ticket that will activate a robot to carry out the repair. Once repaired, it will be reported along with an assessment of the associated energy loss that will be evaluated by a central team of the PV plant or PV plant owner. Another example we can imagine, an automatic drone flies over the plant without human intervention. During one of these flights, a misaligned tracker is detected. An action command is sent to the system to reset the tracker's control system. It doesn't work, and it is determined that the motor is broke. This cannot be repaired with a robot, so a request is sent to a central maintenance team. So this is what the PV sector is needing. So this is what PV plants will look like in just 5 years from now on.
Thank you, Luis.
Okay, so we'll follow up with the next questions. So the next question is for Joao, because it's about TALOS. So Joao, please tell us, what is still preventing PV operations from widely adopting AI and automation? Is it cost, trust, skills, system integration, or what do you think it's preventing them from this?
I think this is one of the questions where the answer is all of the above, and I think it's worth exploring a bit each one of these that you mentioned. I think in terms of skills and workforce gap, we are aware that we have a generalized decline of available workforce, and on top of that, O&M that depends on AI requires two different types of expertise from the workers. So either both expertise in energy systems and as well in data science and data interpretation. And this conjugation is scarce in the current workforce. There's an interesting statistic from 2022 in the US where 44% of the employers in the solar business industry were reporting massive difficulty finding qualified applicants. And so there is already an effort underway to upskill the existing workforce to be able to work with AI as well and apply them in operational environments. But it's still, I think it's still a bottleneck for many companies. Then in terms of trust, I think that, or the lack of trust in AI and autonomous systems, I think it's related to different phenomena. One is more related to technological maturity and another to end user perception. In terms of maturity, even if advances in hardware, software, and most importantly, the integration of both have been quite astonishing lately, there are still many end-to-end solutions that are not exactly at commercial levels, still below TRL9, meaning that they are not really on a set and forget level. And this has important implications. So, for example, in a PV plant, a robot malfunction can increase either the risk of lower output or even cause unexpected downtime. And this, of course, has very real costs for the PV operator. So this is the maturity side of the solutions. I think there's as well a challenge of perception in terms of how we perceive error. So humans, of course, make errors sometimes. O&M teams can make errors. But I think that this can be more easily tolerated because we can understand maybe what caused that error or what was the intention behind that action. Whereas if we are talking about an algorithm, for example, an algorithm that is reaching an unexpected conclusion, a robot that is behaving unpredictably, I think that much more likely operators will question the logic behind it rather than trust it. And I think this asymmetry in how we perceive human versus machine error also helps explaining why the adoption of AI in and the automation in PV systems can be slower than expected. In terms of cost, PV plants are already capex intensive, which is already a change of paradigm relative to other conventional generation sources. And automation adds an extra layer of upfront costs for the project developers. So even if when crunching the numbers for long-term profitability, even if profitability is higher when automation and AI is incorporated from the beginning, the increased upfront costs can be quite a deterrent for many operators, especially those that have a focus more on short-term return on investment. I think, though, that labor shortages, rising wages, and the increasing cost competitiveness and maturity of these solutions will, in principle, create this force that will increase the adoption of AI and automation. And finally, to the last aspect that you mentioned, the integration, which I think often is the elephant in the room. The challenge is that AI and robotics need standardized and high quality data to do predictive analytics or for the robots to operate. The thing is that many PV plants, they either operate on legacy SCADA systems, at least compared to the ones that are more recent. They use different protocols. Sometimes even within the same companies, the data is fragmented within different silos. So interoperability for a robot or software developed that is implementing or trying to implement their solution, this interoperability sometimes it's quite difficult. And so I think that implementing standards and having high quality data streams will be quite important to ensure that we can scale up the implementation of AI and autonomous solutions.
Okay, Joao, thank you very much for your questions. So now we have some questions from the audience. They are directed to Luis, so I'm going to read them to you. So the first one is from Daniel Albuquerque, and he says, "Who's developing this PV assets management software, and what it will be, and will it be free to use open source?"
The asset management software is being developed at one of our partners, Qualifying Photovoltaics, QPV. And it will be an exploitable result. It will not be an open source or open result, but it will be offered to any PV company or any company in the PV sector. We have other tools open. The tool related with the estimation of the expectation, the estimation of the productivity of the PV plants, even with solar trackers or undulating terrains. This will be or is already an open tool called CCFO that you can find at ccfo.info. We are integrating in this tool the new models we are developing for you to estimate the productivity of your PV plants.
Okay, Luis, thank you very much. And there's also another question for you from Daniel. He says, "The algorithm for shadow forecasting is really a 3D tool, or do you use 2D approximation to infer the best angle for each tracker?"
We work with 2D models, because if you go to real 3D models, you need ray tracing and you need a huge effort of computation. So if we want to include this model in our software tools, like Sisyphus, we need to work in 2D models, but we include the third axis, the height of the terrain, the height of the solar tracker. This is why we talk about 3D backtracking. We have not invented this term. The industry of solar trackers is using this term, and we have adopted it.
Okay, thank you, Luis, very much. We have another question. I'm not for sure which project it is. I assume it's PVOP because you were talking, but maybe we both can answer that. The question is from IK. It's a participant here, and he says, "Does the project look for EU manufactured edge AI hardware modules, PCP?"
In our case, not. We are not working on this hardware. We are working on software. We are working on AI algorithms, and we are trying to use new AI algorithms adapted to the kind of failures we are finding in the PV plants.
Thank you, Luis, very much.
All right. So, João, we have a fun one question for you as well. So I was watching your presentation, and definitely there have been some innovations when it comes down to Talos, and some impressive innovations, right? In specific sectors inside of the PV sector, even if it's within the aquatic sector, so with PV plants on in lakes, in rivers, in large scale. But there is this thing about like the PV manufacturing, and we need to reduce the dependencies within the PV manufacturing. So, how do you see Talos contributing to the EU goals of reducing supply chain dependencies, and while remaining cost competitive and supporting domestic innovation in this case?
Thanks, Rui. I think Talos is addressing different types of the supply chain. So basically, by having this software and and the hardware developers, which are European companies, developing and increasing the maturity of their solutions and having them validate them in real world scenarios, this is the clear way to boost the European industrial base, and we are that way de-risking the adoption of these solutions as an alternative to buying them elsewhere. I think then in one thing that also boosts or can boost quite a lot the local supply chains is due to the way that we present our digital platform that coordinates the different robots. So we are striving for a modular and open digital architecture with very well-defined communication protocols. And basically, this allows us to imagine sometimes you have a certain piece of the puzzle, namely this digital platform, which is from a certain vendor. Perhaps they have like very specific protocols to integrate with that platform, and this already locks in our choices in terms of who can integrate with that platform. The fact that we are here promoting a platform with very standard communication protocols and open architectures, this makes the integration of third-party, robots, softwares, much easier. And so this is helping also reinforce the local, let's say that the startup and SMEs, because it decreases the barrier for entering the communication with the Talos platform. This is also why we have this open call. A lot of the startups and SMEs are integrating their solutions with the Talos platform. So we are showing that it's possible to create this environment where anyone can jump in and soon add value without having to have a very specific protocol or a way of integrating with the community with the software. And finally, I think more towards the end of the value chain, the fact that we are involving the end users in the co-creation process, and by to encouraging them to provide feedback on how the solutions are developed, to have these training sessions where they learn how to use the solutions. I think we are already helping the end user base to learn how to use these technologies. Which is, I think, a part of the supply chain, which is often not the one that we think about, but one that also matters quite a lot.
Okay. Thank you. Thank you so
Okay.
much.
Thank you, Joao. And okay, I think for to wrap up this session, there's a question for both of you. So here it is. So it's, where do PVOP and Talos complement each other, and how do European operators benefit from combining digital and robotic solutions? I don't know who wants to go first. Maybe Luis, because Joao just spoke.
I think this combination of artificial intelligence and robotics is the future of PV plants. Automatic performance evaluation and fault detection and automatic maintenance tasks performed by robots. I think that this will be the future. But let's not forget that human intelligence will still be very necessary for this to work. In fact, as Joao mentioned before, one of the major bottlenecks in the PV sector currently is the lack of human resources with sufficient skills or with the skills demanded by the sector. So, what we are doing in PVOP and TALOS is very complementary and very focused on the needs of the current PV sector.
I couldn't agree more. I think that the digital layer and the robotics layer are two sides of the same coin. Let's say here, when the coin is O&M maintenance in PV. PVOP is focusing a lot on data analytics and digital O&M tools, and for the robots, for them to work autonomously, they need this layer of intelligence, but also there are certain tasks that can only be performed they need a physical execution. So this is where TALOS jumps in the equation. And I think it's the conjugation of both robotics and AI that will enable us to have real predictive maintenance, to maybe open the possibility to have 24/7 operations in the field, and to reduce the human exposure to risky or monotonous tasks on the field.
Great. Thank you. Thank you both for coming. I think that there is one comment from IK, Luis. So he says that he understands but AI software runs efficiently only on dedicated AI hardware. Okay, so how are you trying to implement also with AI hardware?
I totally agree, but this is not the focus of PVO project. Obviously, the partners developing these solutions are currently using this kind of algorithms, and they have the required hardware for these algorithms to work properly. But we are, as a project, we are not focused on this hardware. But of course, this is totally necessary.
Great. Thank you so much, all of you, for those who have attended, to the panelists as well. I am going to leave once again here some links for you to see, okay? So you can learn more about the Talos project, okay? You can go and search their website. They have everything updated there, from the results to the open calls as well, and you can follow them on LinkedIn as well. They're very active on LinkedIn. And then also you can check out the pvop.eu website, and also the basically the landing page that we have there for the PVOP solutions, and to book a call with our developers, okay, with the PVOP developers, in case you are interested in the solutions. Thank you all for coming. Thank you all for attending, for your questions as well. Obviously, very, very glad to have you here. And yeah, have a wonderful day. Bye bye.
Goodbye, everybody.
Bye.
Thank you.